So this is your lab 1 matter and measurement report sheet. This is what you have to do and submit it on Canvas. Your very first experiment is determination of the density of a regular shaped object. So you are given a metric ruler. Um, it's a paper metric ruler. It's in your bag, and using that you're going to find the length, width, and the height of this object. Now, based on your computer size, your length, width, and height are going to come out different, but that is fine. But the most important is that when you're using that metric ruler, you have to put the value of length, width, and height here up to 2 decimal places. And I'm giving you an example here. And so it has to be 2 decimal places. If you're writing just 2.5 or 2.4, that's wrong. 2 decimal places, 2 digits after the decimal. Once you have your length, width, and height, ignore this D. You have to calculate the volume, which is, since it's a block, it's a cube or cuboid shape. You find the volume by length, width, and height, multiplying length, width, and height. So now you're multiplying these three numbers. Then once you multiply these three numbers, this is what you see in your calculator. But then we have to see how many significant figures I should put in my answer. So this has 3 significant figures, this has 3, and this has 3. And we are multiplying them. We go by the fewer, but they all have the same. So your answer should have 3 significant figures. So it will be 16.2. The number next to 2 is 4, which is less than 5. That's why we are not incrementing 1. Now for your block, so you're going to have your own values here. For length, width, and height, you're calculating volume here, and you're representing the answer with correct significant figures. It's all about significant figures, so if you're not putting them right, you will lose points. And then I gave you the mass of this block. And then how do you calculate density? Density is basically mass over volume. So in my example, I took mass, this value, and this was my volume. So mass divided by volume. So how many significant figures are in this number? 1, 2, 3, 4, 5. And here are 3. So that means my answer should have 3 significant figures. So I will stop at the first 1.24. What is after 4? Is 3. So we're not going to increment 4 by 1. So then you have to write down your density here. This is just an example. Your data will be different from all this. This is just, I'm doing it on the side so that you can go back and look at it. Your next experiment will be to find the density of an unknown metal, and you're going to use the water displacement method to do this. You have 25 ml graduated cylinder in your bag, and you're going to fill it halfway with the water, and you're going to record the initial volume to the 100th place. Again, 100th place means you need to have 2 decimal places. So I have my example here. Then, so your initial volume will go here. So let's look at, I have put one picture here. If you look here, this level of water here, it is between, look at the big marks, 20 is here and 25. These are my big marks. So first, then I have to find out how much is what each small part. So first you do 25 minus 10, which is give 5. 5 is divided into 10 equal parts. So that means each part is worth 0.5. So if this is 20, 20.5, 21, 0.0, 21.5. So I'm certain about 21.5, and it seems to me it's exact 21.5, so I wrote down 21.50. 2 decimal places. If you do not have 2 decimal places here, you will lose points. Then you will put your metal sample, you are given a bolt, into the um, graduated cylinder, and then you, of course, the level of the water will rise and you will write down final volume of water here. And then how do you calculate volume of the metal? By subtracting these two numbers. So here is my numbers, and again these are the numbers I made up. Your number is going to be very different. So 21.50 was my initial volume. Final volume is 33.55. After I added this metal sample, the mass is given. This is the mass I used. For you're going to use the mass of the metal sample from the bag. It's written on the top of that bag, and that will go here. Now we have the volume of metal, we have the mass of the metal, we can find out the density. Now keep in mind that when you are finding the volume of the metal here, you are subtracting these two numbers. That means you are applying the subtraction significant figure rules. You look at the number of digits after the decimal, and you need to have the same number of digits after the decimal. Then when you're calculating density is mass, which is 15.000 grams, divided by volume, which is 12.05 milliliter. So there are 1, 2, 3, 4, 5 significant figures here, 4 significant figures here. So my answer should have 4. So when I will divide it, I will get a big number in the calculator, but then I'm going to report it with the 4 significant figures here. Now once you got your density, then you're going to compare with the densities given here and write down your unknown metal. Let's say you have to pick the closest one. Let's say you calculated the density, and let's say it came out 11.50. So what is the closest number that you get here? 11.50 is gonna be lead. Lead is the closest value, so you're going to write down lead here. But again, you're going to decide based on this value. This was your experiment part B. The last one, part C, is the measurement activity. For this, you need a 100 milliliter graduated cylinder and 10 ml graduated cylinder. What are you going to do? You're going to take 9 ml of water in the 100 ml graduated cylinder. Now 100 milliliter graduated cylinder, the lowest mark is 10. So if you need the 9 ml, that means you have to kind of stay below the below this mark. That's going to be 9 ml. You can use the barrel pipette, it's in the bag, to make it up to here. Once you have 9 ml water into the graduated cylinder, you have to transfer the water from this 100 ml graduated cylinder into the 10 ml graduated cylinder, the small one. And make sure when you're transferring it and you're reading the graduated cylinder, you're putting your number up to 2 decimal place. So here it was my 100 ml graduated cylinder. I have 9 ml of water here. I transferred it to my 10 ml graduated cylinder. So let's say it's up to here. So when your level of the water is like a meniscus, you read the lower meniscus, and when you're reading the level, you have to have 2 decimal places. And again, this is an example class. I made up these numbers. You're going to have your values here. So you first take 9 ml of water, you transfer it to the 10 ml graduated cylinder, you read the level, you write down here. Then you get rid of the water from both, shake this one really good, both of them, get rid of the water, again take 9 ml of water in the 100 ml graduated cylinder, transfer it to the 10 ml graduated cylinder, write down here. And do the third trial too. Every time 9 ml of water from the 100 ml, transferring it to 10 ml. Once you have these three numbers, and let's go back to my numbers, then you will take the average of these three numbers and divide average of these three numbers. And how do you take the average? You take the sum of the numbers divided by the total numbers 3. Now if you have two decimal places here, 2 here, 2 here, then of course you're going to have two decimal places here. Then this deviation basically means how much each value is getting deviated from your average. So that formula is deviation equals to absolute value of x minus x bar, where x bar is the mean. Absolute value, absolute sign means distance, and distance cannot be negative. So that means if your answer comes out, you do x minus x bar, it comes out negative, your answer will still be positive. So here absolute of x, this is my x and this is my x bar. So x minus x bar, 9.50 minus 9.27 is 0.23, absolute of 0.23 is 0.23. Then this minus this here, and then here this minus this. Now 8.86 minus 9.27 is negative 0.41, but your answer will still be 0.41 because the absolute of negative 0.41 is 0.41. Once you have these numbers, then you again have to calculate the average. So you take the sum of these three and divide it by 3. So you have to do these three experiments, A, B, and C. You will have your own data here. This lab 1 measurement, mass and measurement, this report sheet is there on Canvas in the doc format. You download it and you just type everything there. But make sure you're taking the pictures when you're doing the experiment. And you have to copy paste those pictures into this document. So that I know that you did the experiment. Now, so you're going to take the picture of each setup. You're going to transfer those pictures to your computer and then copy paste the pictures into this Word document. Then you will save the Word document as L1, Lab 1 Matter and Measurement. Then your first name, your last name, and today's date. And then you're going to upload it under L1 Matter and Measurement Lab Report. Again, it is on the Canvas and you can upload it there.